So our next topic is your AI has 99 problems, why high-quality data is the key to production-grade AI systems. To present this topic, we have Emmanuel Turlay. He's from Airtrain AI. Emmanuel is the founder and CEO of Airtrain AI. He's worked on ML pipelines since 2017 at Instacart and Cruise. With Airtrain, Emmanuel aims to democratize the kind of powerful tools that large tech companies use every day to achieve impactful results in ML and AI. He holds a PhD in physics from the Paris Sud University. Welcome, Emmanuel.
Thank you very much. So my name is Emmanuel. So I'm going to try to convince you today that the solution to most of your problems as you're building AI system is to think about data. It may not be as sexy as optimizing your prompt or your parameters, but data for the last 10 years has been the biggest impact possible to the quality of systems, even before GenAI. So I started my career about 15 years ago doing particle physics research at CERN, and this was before the term machine learning was even popular. At the time, we called it multivariate analysis. So we used to analyze collision data from the collider at CERN using things like machine learning, and you can imagine the amount of data that we had to process there. So this is where I started, and then I went on to work at Instacart as a full-stack engineer, building all sorts of back-end systems for the company. And eventually, I joined Cruise, which is where I really developed more my expertise in machine learning infrastructure. And I left Cruise to eventually found Airtrain AI, which is what I'm doing today. So first thing I want to start with is something I put into ChatGPT a few months ago, which is, please generate an abstract image to illustrate the following statement. Top problems to put AI systems in production. So I'm not even talking about data. I'm just saying what are the problems that people encounter to put AI systems in production. And funnily enough, this is what came up. So you can see a number of statements on here. For example, you can see that one of the problems is scalamity, whatever that is. Okay. Model robustness. Okay. But beyond the joke, you can see 3 times data quality. So ChatGPT knows, has scraped the entire web, has trained on the entire web, and they already know that one of the biggest problems to put AI systems in production is data quality. So as the title of my talk was, your AI systems need higher data quality. So what do I call AI systems? There's many different layers of it. The most basic one is obviously just the LLM itself. So you have all those big companies, OpenAI, Google, Anthropic, that are producing those LLMs. So it's like a neural network, essentially. So this is kind of the most basic component of your AI system. Now, the first thing that people started to build on top of those LLMs are chatbots. Essentially, a chatbot is an LLM, and what you add around it, maybe a UI, UX, but essentially it's a system prompt. How do you instruct the LLM to respond to user queries so that the LLM acts like a chat partner? Okay, so that's another layer of AI system. On top of that, has been discussed just before, RAG is another one where you have your LLM, you have also a system prompt, and you add on top of that some knowledge that is specific to maybe your domain expertise or is more recent than the last training data from the model itself. So that's another layer of complexity around the LLM. And then now what's extremely popular right now are agents, where you can have many different parts to it. So obviously you have the LLM in the middle, some system prompting as well, sometimes some knowledge, and oftentimes API calls to actually make things happen. This is really what agents are. They get some intelligence from the model, and then they act on it by either calling an API, like a web API, or maybe taking a screenshot of your computer so that they can figure out what's on it, and so on, how to click buttons, and so on. So I'm going to try to convince you that in all those cases, whatever you're building, maybe you're not a top AI engineer at Anthropic building Claude. Maybe you're building an agent. In all those cases, you need to worry about data. So biggest question is, should you care about data? So starting from the most bottom layer, let's say you are pre-training an LLM. So pre-training is the sort of first and most expensive phase of training an LLM. You start from scratch. Your neural net is randomly initialized, and you train it on trillions and trillions of tokens of data. So not all of us do that every day, but This is how we get those big models. So if you look at the blog release of Llama 3, and I was hoping to be able to read here, but I guess I'm going to try to do it over here. So they mentioned the Llama 3 is pre-trained on over 15 trillion tokens that were all collected from publicly available sources. So essentially, probably web content and the likes. And if you read further, to ensure Llama is trained on data of the highest quality, these pipelines include using heuristic filters, NSFW filters, semantic deduplication approaches, and text classifier to predict data quality, mixing data from different sources in our final pre-training data set. So it's been proven by researchers that the biggest leverage you have on making your LLM high quality is the data itself. Changing the hyperparameters, changing the architecture of the model doesn't actually have as much impact as optimizing the mix of your data, the quality of your data. Now, if you want further proof, this is Llama 3, so this is a pretty large model. But you can look at the technical paper for Phi 3. Phi 3 is a fairly small model from Microsoft with 3.8 billion parameters, so pretty small. And they mention here very explicitly, the innovation lies entirely in our data set for training. So they don't even say, oh, we found a great new architecture, or we optimize our parameter. They say the innovation lies entirely in our data set for training, a scaled-up version of the previous one, and so on, composed of heavily filtered publicly available web pages and synthetic data. So once again, they tell you it almost doesn't matter the shape of your model, of your architecture, of your neural net. What matters the most is the quality of your training data. Okay? So now we're not all doing pre-training. You know, this requires a lot of knowledge and expertise and a lot of money as well. But maybe some of them are fine-tuning LLMs. So just to remind you, what is fine-tuning? It's another step of training after the main body of training that we just discussed. It's usually much more, much cheaper and much easier to do. You can fine-tune with a few thousand rows of data. And the goal of fine-tuning is to specialize your model for a particular task or a particular tone, and so on. So it's not like RAG where you add knowledge. It's more how do you shape the model to speak in a certain way. So it's a very matter of specialization. So if we look at this paper, which was the Phi 1 paper, so we just looked at Phi 3 just before, this is Phi 1 a few months before, where essentially they mentioned that they took a very small model, 1.3 billion parameters, so that's 3 orders of magnitude smaller than a GPT-4, for example. And what they did was that they used very high quality, textbook quality data, as they mentioned, to train the model how to code and how to solve coding problems. And this model is extremely small, and when you look at its performance, here you have the results of how the model performs on certain coding benchmarks. You can see that it performs better than almost all the other models out there, regardless of size. You do have a couple models that perform better, notably GPT-4, GPT 3.5 and 4 at the time were performing better, but that's with 3 orders of magnitude bigger. So the point here is that if you have a small model, you can make it perform it almost as well as a very large one if you have a very high quality data set on which you can fine-tune it. This is pretty important because in some cases, for some applications, the cost of those large models of GPT-4 and so on is prohibitive. If you have to apply your model to hundreds of millions of rows in a data set, for example, it may be too costly, it may be too slow, the performance may be too slow. So you can actually achieve similar performance on specific tasks if you have a high quality data set on which you can fine-tune your model. So hopefully I was able to convince you that fine-tuning only works if you have a high-quality data set. So maybe you're not fine-tuning, but a more popular application is RAG, as was discussed already before. It's one of the most popular applications of LLMs. And as you know, a RAG, essentially you take user's query, you query for knowledge in a knowledge base, and then you feed this knowledge to the context window of your LLM to generate a summary of the response. So obviously, the first part to make this work well is to have a good knowledge base. So when you send your user's query to your graph database or to your vector database, you need to make sure that the content of this database is relevant. So you need to care about data quality. Don't just shove any old data into the system. the responses will be garbage. So you need to curate the quality of the knowledge base. It means sometimes making the knowledge base smaller, removing the spurious contents, the one that is irrelevant, and so on. So as I mentioned, knowledge base is the first thing you need to worry about in terms of data quality. Now, if you want to measure the quality of your RAG system, you need to evaluate the various parts of it. So the retrieval part, how relevant are the responses I get from my vector database based on the query input by the user. So that's the first part you need to evaluate independently. And then the second part, given a set of documents that I got from my database, how relevant and accurate is the summary generated by the LLM. So in both those cases, you need to evaluate those components. And evaluation in those cases means curating a data set, an evaluation data set of ground truth so that you can compare it against. So there's a bunch of metrics out there. RAGAS is an open source framework that you can look up. There's a bunch of metrics out there to measure the quality of a RAG system with different metrics for different parts of the process. So once again, if you want to have a RAG system that works well, you need to worry about not only the source data, the knowledge base, but also the evaluation data that you use to measure the performance of your system. Okay, so that's for RAG systems. Maybe you're not building a RAG system, maybe you're building an agent. It's very popular these days, so maybe you're building an agent. So here I want to bring an analogy that was actually brought up before by Ivan, mentioning about unit testing. So for those of you that are software engineers, you're probably familiar with test-driven development, meaning that in traditional software, you typically you find a bug in production or as you're testing your software. And so before fixing the bug, you first write a test to reproduce the bug. Okay, the test is going to fail because I have a bug in my code. And then I fix the bug, the test passes, and then I just keep this test forever in my test suite. And so I'm going to grow over time my test suite so that I can always make sure that when I ship new code to production, this bug does not reappear. So this is a pretty common practice in software engineering. Everybody does that. This is how we make sure that we can ship code quickly to production without breaking things. How did that work in the AI world? Well, very similarly, you will find instances where your system has bad responses. Okay, so you find those bad responses as you're testing or directly in production. Maybe a user has complained about something. So you collect this particular prompt, this particular input. You extract it into your eval data set. And you maybe try to improve the system prompt or the code of your agent or of your AI application to avoid these failures. Maybe it means adding a number of clauses to the system prompt to tell the model, do not do that, do not say those things, you're not a financial advisor, whatever, any of those kind of type of guardrails. And then you can keep this test forever in your eval data set, and your eval data set grows over time to a few hundred, a few thousand instances. And then you can use this to run a test suite before you deploy your code to production. So the difference between the two approaches, though, is that in traditional software, you have pass or fail. Unit tests, either they pass or they fail, so it's pretty easy. If you have a green or a red icon, you know if you can ship to production. In AI, obviously, because those answers are fuzzy, it may not be as straightforward. So you may need to fiddle a little bit with your evaluation metrics to understand what is the threshold with which I'm comfortable shipping to production. So you need to design some metrics that have a range of values, and you need to decide the thresholds that are required. So essentially, the point I'm trying to make here is that you should treat your eval data sets the same way that you treat your test suite. Just as important in that way for your AI application. Okay, so hopefully I convinced you that creating data sets is very important, whatever you're doing in AI. But how do you even go about building a data set? Well, there's a lot of open data sets out there. Thousands of them are available on Hugging Face, for example. I'm pretty sure there is one that is related to your application, whether you're working in healthcare or transportation or any of those sort of verticals. You can find a data set that is appropriate for you there. Obviously, you will have to create it maybe further, but that's a great place to start. So you can already start there and then pass this data set through your application, see how it performs. Another way to build a data set is to scrape the internet. So this is essentially how those big foundation labs create their own training data set to train their own models as they scrape the entire internet. Obviously, It's a lot of work, but if you have a specific application, maybe you can scrape websites that are specific to this application. So this is a Python library that is very useful to scrape HTML pages. So it's pretty easy. In a dozen lines of code, you can write a script that will scrape the internet using Beautiful Soup. That's another way to create a data set. Another one is to generate synthetic data. So that's an amazing application of GenAI, is that you can ask models to generate data for you. It can be as easy as just prompting one of those models, please generate a few dozen entries of maybe first name, last name, email, bio, if you want to create a data set of those things, or any such data. There's also a number of tools out there to make this more efficient. So this is a Hugging Face space built by Argilo that essentially you start with the prompt, and then they will show you some example data, and then you validate the ones you like, you don't like, and then you can generate further data. So that's a pretty good way to get started. But the best way to build a data set is really to use real production data, because your evaluation data set is only as effective as it is close to your actual production data. The same way that when you write software, sure, you can write some tests to avoid bugs, but essentially it's by shipping to production that you will really see the kind of errors that users are running into. So start saving all your the traffic from your apps in a database. So it means all your prompt, all your responses, maybe the intermediate steps. If you do RAG, save the list of documents that were fetched for every request. And this should be the basis for your evaluation data set. So you need to obviously curate this, because there might be many of the data in this in your production database may not be useful. So you will have to look at it maybe by hand and handpick the few entries that are important, especially the bad ones, especially the entries where there's a failure. If the user was frustrated, moved away from your app, closed the app, didn't purchase, didn't do any of the actions that you were trying them to do, this is what you should look at. Why did this user fail his journey through your application? So focus on those maybe. Now that you have a data set, what is data curation? So you can take this analogy, essentially, of you have a very messy tree that you've let grow over the years, and it's full of dead leaves, dead branches, and then you trim it, you prune it. You remove all the useless branches, and you'll try to keep only the core. So creating a data set is very similar. You try to distill a large data set to the most important parts. So what is important to look at when you're creating a data set? Well, you have to monitor data duplication. So sometimes you have the same data multiple times in your data set. Sometimes it's exactly the same copy of the data. Sometimes it's semantically similar, meaning not exactly the same words, but the same meaning. And you may want to deduplicate. Sometimes duplication is actually useful if you're trying to fine-tune a model to really focus on one particular type of answer. You may need to have overrepresented samples of this type of data in your data set. So this is why I say don't avoid duplication, but monitor it. Make sure you know how much duplication there is in your data set. Then diversity balance, you want to make sure that there's all types of data that really represent your production distribution in your data set. So make sure you bucket your data, you label, you classify it, see how many of each types of each topic or area are present in your data set. Identify outliers. Some data may be just way out there. Maybe you don't care about it because it's an unintentional usage of your system, but maybe it actually is an intentional usage and you never thought that somebody would use your product like this, and now you need to care about it. You need to find low quality data, so things that are maybe poorly formatted or a wrong answer. You can fix it or trim it, remove it from your data set. And then eventually, I would really encourage you to browse your data manually. If you talk to data scientists and ML engineers, they spend most of their time just scrolling through data and looking at the data. So you can use all the tools you want, but essentially your brain and your eyes are the most powerful way to even understand your data. There's a common phrase in industry that says you need to become one with your data. So you need to look at your data, scroll through pages and pages of your data set to really understand what's in there. Now, what tools can you use to do this? Well, there's tools like semantic clustering that will automatically find buckets in your data sets using embedding space, and we'll label them. So you have an example here of a visualization that we offer in Airtrain to find the different buckets of data in your data set. So that's kind of unsupervised classification, if you will. A lot of our customers have used those tools to even discover the content of the data set. They didn't know, oh, some people are doing this in my app. I didn't know. And maybe sometimes 10% of your data set actually ruins the entire data set. And if you don't, not aware of this smaller sample, those niches in your data set, then you're in trouble because it can really ruin your application or your model. Then you can do classification and labeling. You can try to bucket, you can come up with your own taxonomy of data types or types of inputs and outputs that are in your data sets and apply this to your data set to make sure that it's well balanced according to what you're looking for. Embedding space exploration is another very powerful tool. You can see a visualization here on the bottom right where essentially you can project those very large vectors of thousands of floats onto 2 or 3 dimensions so that you can explore it manually. You can browse through it, you can find similar entries side by side, you can find outliers that are not within any clusters. It's very useful to discover and understand your data sets. And the final most important tool to create your data is your eyes. I just said this before, I say it again, all those tools will not save you from scrolling through pages and pages of data to understand the content. So hopefully I was able to convince you that looking at data and understanding your data sets are very important. This is why we built Airtrain AI. We're trying to help people really understand the content of their data set, being able to distill it down to the highest possible quality data set, and also offer things like semantic clustering, classification, and so on. And that's it for me. Thank you.